at antiderivatives with conditions. So the idea is that we're solving differential equations, basic ones, but still, and we want to figure out what that c value is now. All right. So if you take a look at the first example, you see we have capital F of x is equal to the indefinite integral of 3x squared minus 1 dx. And so we've got to integrate that, but we're going to get a plus c at the end. So let's take a look. And so antiderivative of 3x squared is going to be x cubed minus x, antiderivative of the 1, plus c. All right, so what they told us here is that f of 2 is equal to 4. All right, so f of 2, which is what you would get if you replaced each x value with a 2. So 8 minus 2 is 6 plus c. That's actually going to be equal to a 4. Right. So 4 is equal to 6 plus c, which means that c has to be equal to a negative 2. All right, so what that tells us is our particular solution is going to be f of x is equal to x cubed minus x minus 2. All right, but that's only because we had the condition. If we didn't have the condition, we wouldn't be able to determine the value of c. All right, number 2, same idea. It says g prime of x. All right, so it's not written as a antiderivative, so we got to take care of that. So let's just fix this real quick. So this is the same as saying d g of x dx. All right, so differential equation. Now let's get it in differential form. D g of x would be the same as saying 6x squared dx. Just multiplying both sides by dx. Now if I integrate both sides, understood 1 here, the antiderivative of 1 with respect to g of x. Right, so if it were with respect to x, I would say it's x. If it were with respect to q, I would say it's q. So if it's with respect to g of x, it's going to be g of x. Right hand side, increase the exponent by 1, divide by the new exponent. We're talking about 2x cubed plus c. All right, now they give us the condition, and that is that g of 0 is equal to negative 1. So if I plug in a 0 for x, I get just a c on the right hand side, and since we know g of 0 is the same as negative 1, we now know that c is equal to negative 1. So therefore, we can conclude that g of x is equal to 2x cubed minus 1. So now let's get out of that frying pan, just dive right into the fire. We have s of t, or more correctly I should say, we're looking for s of t if v of t is equal to the antiderivative of a of t. And so v of t, antiderivative a of t dt. All right. Now they give us a condition, wonderful news, all right, and that is v of 0 is equal to v sub 0. All right. So, but let's anti-differentiate. So the antiderivative of a of t, regardless of what they actually stand for, velocity, acceleration, position, let's just pretend we don't know any of that. And maybe you didn't.Maybe I just kind of blew the surprise. All right. But if I were to anti-differentiate this, I'd kind of be in a little bit of a bind here, or at least if I attempt to anti-differentiate, because there's only a couple of different places I can go. One way would be to say, well, lowercase a becomes capital A. Right? So that's one possibility. Another possibility would be, like if I made an assumption assume that the a value is constant, then I could say it's a of t times t, but I can't make that assumption. So for now, I'm just going to say it's capital A of t plus c, and that's what v of t is equal to. Okay? So they gave us a condition, and that condition tells us that v of 0 is going to be equal to v of 0, all right? V sub 0, I should say, all right? So replace all of my t's with zeros. And what I'll get is a lowercase v sub 0, or lowercase, uppercase. It doesn't matter for the v's just yet. It does matter with the a's. All right. A of 0 plus c. All right, so I can now solve for c by saying that it's equal to v sub 0 minus a of 0. All right, so if I want to put this in its most general form, I could say, we're looking for a particular solution, but particular solution in general terms. V of t is equal to a of t, capital A of t, plus v sub 0. I'm making, slowly but surely making my lowercase v's look more and more like capitals. So let me fix that. Minus a of 0. All right. So we're talking about capital acceleration, whatever that means. We'll get to that in a couple of minutes. All right. So, because there are some facts that if you know them, it streamlines things, but we want to operate under the assumption that we don't know what those relationships are. All right? We're trying to discover them. So, now what I want to do is find S of t. Now, I'm kind of talking out of both sides of my mouth here, because in the next step, we kind of have to make an assumption that goes along the lines of, the assumption that we're trying to kind of pretend we don't, or a fact that we kind of don't know. All right, so we're actually going to throw this in the instructions and call this another relation or a rule. So if S of t is equal to the antiderivative generally of v of t dt. All right, so that's going to allow us to take the next step, which is to say that S of t is going to be the antiderivative of all of this stuff dt. So the only thing that's variable in this whole thing is the a of t. So we'll just leave that as an antiderivative. But we could actually integrate the VO. That's going to become VOT. And we can anti-differentiate or integrate the a of 0, because that's a constant value. You plug a 0 into your acceleration function for all your t's, you're going to get some numerical value as a result. So minus a of 0 times t, all plus some value c. All right, so what we're going to do now is evaluate this for 0. So S of 0, antiderivative a of 0 dt plus VO times 0 minus I keep saying O, a of 0 times 0 plus c. Okay. So ultimately, I mean, really, if you kind of play it all out, what we're looking at here is going to end up being the same as what we had here, only when you evaluate though. So that is going to result in the same, or I'm sorry, the opposite computation as this one, but it really doesn't matter. It's going to have a 0 in it. All right, so these are all going to wipe away. We know S, so S of 0 is S sub 0, and that's equal to C. All right, so at long last, we can draw our conclusion, and that is S of t is equal to the antiderivative, because we can't go uppercase of an a value. So we'll leave that as an antiderivative, plus v sub 0 t minus a of 0 times t plus s sub 0. So that's this relation in its most general form.